Hi, my name is Bucci, and today I'll be showing my Project 1 Step 2 for Wordle Attack. Wordle Attack is a two-player game where two players select their own personal word for each other to guess. Each player takes turns trying to guess each other's own personal word. Like Wordle, colored clues are still given out for each letter position: yellow for correct letter but wrong position, and green for correct position and correct letter. But if a player uses a letter that's in their own personal word, it gets marked as orange, and the opponent can see that that letter is in their own personal word. The game ends when the first player guesses the correct personal word from the other player, or when neither player is able to guess the personal word within 6 guesses. To apply Minimax, let's consider the root node the empty board state, and every other node another possible board state from that root. Leaf nodes are terminal states with a utility value that reflects the sum score of the guessed words at that point. Let red be the computer and white be the opponent. The pink arrows show values are back propagated considering the opponent will make the optimal decisions. This reflects the possible guesses the computer can make from that point, while considering the opponent will not make a guess that will give the computer more information. Since there are over 2,300 possible words for Wordle and 13,000 five-letter words in the English language, we can use pruning to reduce the amount of possible board states we need to explore. We use alpha-beta pruning to eliminate trees of board states that will not be chosen because better options have already been found. If you look at the left tree, we can see that 5 was propagated up to the second level because at least a guess of score 6 will be selected by the computer, which would be greater than the best score that the opponent could give. After pruning, we can use a heuristic to evaluate the current game state and how close a goal node is from the computer's position. Since we know what a goal state looks like, we can directly calculate the distance of each guess. Using the current guess's score of the computer, we can subtract it from the goal state to find a static board estimation to measure how close the current board state is from a winning state. Doing the same with an opponent score, we can measure how close an opponent is to winning and weigh riskier options accordingly. This project will allow students to apply search algorithms to abstract problems, and this project will give experience with working with modern day applications and how AI can be used in unexpected areas.